Good day everyone, welcome to our physics class. I am Jaya Cherise Gumono, your presenter for this topic. So today I will be continuing the discussion of Miss Arlene Islip on emission spectra. But this time I will be talking about line spectra. But before we proceed, let us read first our learning objectives. So at the end of this topic, you should be able to A. Define line spectra, B. Describe the characteristics of line spectra, C. Differentiate line spectra from continuous spectra, and D. Explore the different applications of line spectra in different fields. So, first, let us discuss what is an emission spectra or line spectra. Okay, so the line spectra are also known as discontinuous spectra. So the line spectra are sharp lines of definite wavelengths or frequencies. These can be absorption lines which appear as dark lines in a bright background or a bright emission lines that appear on a dark background. So suppose light from a hot gas is allowed to pass through a prism, then the line spectra can now be observed. So take for example this picture. So this picture is showing a lines, and these lines are what we call as the line spectra. So as you can see, there are associated bright and dark lines in this picture. So and these lines are what we call the line spectra. Okay, so such spectra arise due to the excited atoms of elements, and these lines are the characteristics of elements, which means it is different for different elements. So take for example in this picture. So this picture is showing the spectra of the atomic hydrogen, and this one is also showing the emission spectrum of an ion. So as you can see, there are different lines associated between these two elements. So this difference is showing that element hydrogen is different from the element iron. So next, the line spectrum shows only certain wavelength within a given range, and these wavelengths are very sharp lines with well-defined boundaries. This type of spectra would either be emission or absorption spectra. These are the characteristics of a line spectra. So now, let's proceed with the differences between the continuous spectrum and the line spectrum. So, Miss Arlene Islip has already discussed to you what is continuous spectrum. Now, I will describe you the differences between these two spectrum. Okay, so continuous spectrum has all wavelengths within a certain range, while the line spectrum contains only a few wavelengths within a certain range. So that's the difference between the two spectrum in terms of the wavelengths in their certain range. Okay, so continuous spectrum contains non-observable gaps, while line spectrum contains huge gaps between lines or bands, and that's the difference between the two spectrum in terms of the gaps of the lines. Next, the continuous spectrum is a combination of the absorption spectrum and emission spectrum, while the line spectrum is either absorption or emission spectrum. The example for continuous spectrum are rainbow and black body radiation, while the example of line spectrum includes the hydrogen atom, which I was being shown katong gipakita nako kaganihan na picture. So that's an example of line spectrum of an hydrogen, also is katong iron. So that's the difference between the two spectrum. But basically these two spectrum are classified as emission spectrum. And to further describe the differences between these two, the table will further give you a detailed explanation of the difference between the two spectrum, the continuous spectrum and the line spectrum. Okay, so now let's proceed with the applications of line spectra. Alright, so the line spectra are essential in various fields of science and technology due to their unique properties and applications. And here are some of the common applications of the line spectra. So first, we have chemical analysis. Now, when can we say that line spectra can be applicable for chemical analysis? Okay, So the line spectra are used in analytical chemistry to identify elements and compounds, and this element has a unique light spectrum which allows the scientist to determine the composition of the unknown substances through the process called spectroscopy. Okay, so the next application is astronomy. Now, when can we say that the light spectra can be applicable in the field of astronomy? Alright, so this is by this way. The light spectra are crucial in astronomy for studying the compositions of stars and galaxies. So by analyzing the emission of absorption lines in the spectra of celestial objects, the astronomers can determine the elements present and their abundance. Okay, so next is the medical imaging. So now, light spectra can be applicable in medical imaging in such a way that it plays a vital role for such procedures or medical techniques, just like MRI or what we call the magnetic resonance imaging, and the PET or what we call the positron emission tomography. So these techniques rely on the interaction of atoms with electromagnetic radiation, leading to the generation of characteristic light spectra that is used for imaging. Also, the light spectra can be applicable in material science. Now, when can we say that light spectra can be applicable in this field? Okay, so light spectra are used in material science to study the electronic structure of materials. So researchers can gain insights into their properties such as conductivity, transparency, and magnetic behavior. So next is the environmental monitoring. Now, the light spectra are employed in environmental monitoring to detect pollutants and contaminants in air, in water, and soil. So spectroscopic techniques utilizing light spectra can identify and quantify various substances that are present in our environment. So basically, light spectra can be used in that matter as environmental monitoring. Okay, so the next application of a light spectra is forensic analysis in the field of forensic. Okay, so the light spectra are used in forensic analysis to identify and compare trace evidence found at crime scenes, of course. So by analyzing the light spectra of samples, forensic can determine the origin and composition of materials to assess in criminal investigations. So that is the application of light spectra in terms of forensic analysis. So next, we'll proceed with another application of light spectra in telecommunication. So light spectra are used in telecommunications for signal processing and data transmission. The optical communication systems rely on the manipulation of light spectra to encode and transmit information through fiber optic cables. And next will be nanotechnology. Now, when can we say that light spectra can be applicable in nanotechnology? Okay, so the light spectra are essential in nanotechnology for characterizing nanomaterials and nanostructures. Okay, so the spectroscopic analysis of the light spectra will help the researchers to understand the electronic properties and the behavior of nanoscale materials. So this will be the applications of the light spectra, which demonstrate the significance of the light spectra in a wide range of scientific disciplines and technological advances. So this will be the highlighted the highlighted concepts of this topic. So to summarize, first I am discussing about the definition of the light spectra, then the description of its properties, then the differences between the light spectra from the continuous spectra, and also the applications of the light spectra. Okay, so that would be all. Thank you for watching, and can enjoy sumunod. Good day.